I'm going to do the 2007 Form B question 4 from the AP Calc exam. All right, it says let f be a function defined on the closed interval -5 to 5 with f of 1 is equal to 3. The graph of f prime, the derivative of f, consists of two semicircles and two line segments as shown above. All right, so this is the graph of f prime. If I was going to ask this on your Chapter 5 exam, since we haven't talked much about antiderivatives, we'll be learning more about that in the next chapter. I would not ask for the solution to part D. So I might say find the location of the local minimum value on the open interval. So that way you wouldn't have to check the endpoints. All right, that would be the only edit for this question. All right, so for part A, it says let for -5 to 5, find all values of x for which it has a relative max. Justify your answer. Okay, whenever we talked about relative maximums or local maximums in class, usually we talked about the chart for f prime. All right, so since we have our graph of f prime over here, we're worried about when f prime is positive or when it's negative. So it's positive here, positive, and then negative. Okay, so we're worried about when it's above the axis and below the axis. Okay, so we have points of interest at -3, 1, 2, 4, and that's it. Okay, the reason I put 2 there is because we kind of don't know. It's positive and positive, but it might be undefined at 2. Actually, this one I think is okay. So the slope is, yeah, at, basically there would be like a corner or cusp there if you think about it. So no, actually there wouldn't be. I'm lying. So this is from 1 to 4. Okay, because the numbers do approach the same number. So the slope is from the left and the right. It's going to the same value for your slope in your original. Okay, so anyway, so if I plug in, or if I think about when it's positive and negative, it was positive, negative, positive, and then negative. So what this means is it's increasing, then decreasing, then increasing, and then decreasing for f. Okay, so we need to justify our answer. We cannot use the chart to justify our answer on the AP Calc exam. You have to write out what was used. So I notice that there's going to be a max at -3, and there's also a max at 4. So there's 2 different locations. Okay, so I need to write that since f prime was positive on -∞ to -3 and negative on -3 to 1, there is a relative max or local max at x equals -3. And then I do the same thing. So since f prime was positive on 1 to 4 and negative on 4 to infinity, there is a relative max at x equals 4. Okay, B. So on -5 to 5, find all values of x for which the graph of f has a point of inflection. So when I think of points of inflection, I think of my second derivative. Okay, so when I look at f prime, my graph that's given, my second derivative is going to be represented by the slope of f prime. Okay, so my slope is positive, and then it's negative, and it's negative, so it's going down all the way to here, and then it's positive, so positive slope, still positive, then it's a negative slope from there on. Okay, so my points of interest on this one are -4, -1, and 2. Okay, so my slope was positive, and it was negative. And it was negative, positive, and then negative. Okay, so it's concave up, concave down, concave up, concave down. So there's points of inflection at -4, -1, and 2. So I think on this one, instead of writing out each individual thing, it would be okay to say since something like since f double prime changes sign, because you're really just worried about where you have a point of inflection, not where it's concave up or concave down. Since we were talking about the relative max, you needed to say it went from plus to minus. But if I just asked for like the critical values or something, you could just say that it changed or it equaled 0 or it was undefined. So since f double prime changes sign at -4, -1, and 2, there are points of inflection there. Okay, C, find all intervals on which the slope of f is concave up and also has a positive slope. Explain your reasoning. Okay, so we need to kind of combine these two graphs. So it's concave up from -infinity to -4, but it was increasing from -infinity to -3. So where those two things overlap is just from -infinity to -3. Okay, then look for the other places it was concave up. So it was concave up from -1 to 2, and it was increasing from 1 to 4. So where do those two things overlap? So if I have -1 to 2, and then I had 1 to 4, they overlap. So -1 to 2, 1 to 4, they overlap right here in the middle from 1 to 2. Okay, and then that's it. So in order to justify, you would say, so these two locations, oh wait, oh, you know what, it's not -infinity. It's only on this interval, so it was from -5 to -3. So be careful. We weren't defined all the way to -infinity. So -5 to -3 and 1 to 2. And you could say f is concave up when f double prime is greater than 0, and f is increasing when f prime is greater than 0 at these locations. Both are true. Something like that. So you're recognizing that f double prime is greater than 0 and f prime is greater than 0 in those two locations. Okay, and then like I said, part D we'd probably edit if I was going to put it on this test. So D says find the location of the local minimum value. All right, so D, if I was finding the location of the local min, it looks like it's right at 1. So at x equals 1, there is a local min, or relative min, either way. And then you could say because f prime changed from negative to positive. Okay, so in the original problem, so before my edit, it said find the absolute minimum value. So in order to do that, you would actually need to find what f of 1 is, what f of -5 is, and what f of 5 is, because you need to check the endpoints. And in order to find f of those values. So f of 1 is easy, it's 3. So that local min would be 3 at x equals 1. But you also would need to check the endpoints as well. And we can't do that without learning integration, which is antiterivatives. All right, so that's the end of 2007 Form D.